So my name is Vojta, and I work at a company called Ableton. We build music software and hardware, and I am an iOS developer there. But today I won't be talking that much about iOS, actually. I'll be talking about build systems. I'm super happy that the previous talk actually was rated one of the most useful talks in the recent history, because this one will not be useful at all. It's just for fun and entertainment. Don't do anything what I'm talking about here at home. Okay. So, build systems. I had no idea what a build system is before Xcode 9 was released. And if you remember, Xcode 9 came with a new feature. It was a new build system. And everyone who back then knew what the build system was super excited about that. And I also wanted to be excited, so I tried to learn something about build systems. And what I basically found out is that build system is a program that knows how to build another programs. So it's just a program that converts a bunch of your Swift files and asset catalogs and storyboards into something that you can install on your device and run. So how hard this could be? Turns out it's pretty hard, because the new build system by Apple has been around for 2 years, and it still doesn't work perfectly. So I thought that I would write my own build system, because it's supposed to be easy, and that's the easiest way how to learn about new things, that you just do that, right? So what is this talk not about? This talk is not about how to write a complex and universal build system that you can really use in your real life or even just for some hacking. Don't ever use it in production. This talk is about how to write a simple, non-reusable bash script that builds just one concrete iOS app the simplest way possible. So we will basically take an app and we will build it manually without Xcode. And that's it. That's all my slides. And the rest, I'll show you. So we have an iOS app that I called Hello Berlin, because Hello World was already taken. And I open it in Xcode. This is what it looks like. It's a simple vanilla iOS template app. It's just a single view app. And the only change I did was that I put this nice emoji here. So we just see that it really works. So it's not just a blank screen. You see that it's all empty. OK, so that was all Xcode for tonight. We will not need it anymore. Let's take a look how the app looks like in the folder. So this is the app. This is what Xcode generated for us. So it has 2 Swift files, one app delegate and one view controller. It has one info plist. Oh, ooh. Sorry. Oh my God. It has one info plist file. Then we have an asset catalog, which is empty, so we're going to ignore it. And then we have 2 storyboards. One for the launch screen and one is the main storyboard. Another important file or folder is actually the Xcode project file. In this file or folder, all the information about how this Hello Berlin app is supposed to be built is. And we're going to ignore it. We don't need it. Because our build script is not a build script that will be able to build any app. It will be a build script that will be able to build just this one app, just the Hello Berlin app, in the state in which it is now. So I feel free to actually delete it, because we don't need the Xcode project file at all. OK. And then we have just one file here. I created it earlier today. And it's the build system. It's the build.bash. And that's the script we're going to work on tonight. And hopefully, in the end, in like 25 minutes, we'll see that we're able to build the app. So basically, in 25 minutes, we'll get to the same result that you get after like 10 seconds when you press Command B in Xcode. So what is inside the build.bash now? Let me just rearrange this. Not much, really. It's just the very beginning. We just say that, OK, if anything what we are doing in this script fails, just end the whole script. We just define some project name. In our case, it's Hello Berlin. We define the bundle directory, and this is the most important thing. This is the output of this whole script. This is the .app bundle that, in the end, we will take and we will copy it into the device or into our simulator. And then we will need some place where we can put some temporary files, which we need during the build process. And step number one is easy. We just prepare this working folders. So we remove some old ones if we had some, and then we create new ones. We start very, very easy. Let's run it. Get some nice green arrows here. And you see that, OK, we have the output folder, helloberlin.app, and some temporary folder. No one is probably surprised at this point, I think. So what next? Any ideas?
Run it again.
Oh. No. It's not in, no. No. That's a good tip, but we'll get to it. I would actually start with the Swift files, because that's where the code is. So if we want to compile Swift files, we can use the Swift compiler that actually lives by the name SwiftC. Okay, a lot of things here. I didn't lie, it's a Swift compiler. And it works like any other compiler. You just take a bunch of files, a lot of parameters, and hopefully you'll get some result in the end. Let's try it. Okay, so this is the step one, prepare working folders. Step two, compile the Swift files. We have to tell our script where all the Swift file live. Then we say, OK, we want to take all the Swift file there. And here you can see why basically this will never work for any real app, because it's not always true that any Swift file inside this directory is the Swift file that belongs to this specific target. This is true just for our app, and we can just hardcode it here because this script will never be used for anything else. We specify the target architecture. In our case, at this point, we are building for a simulator. And then we also have to provide the path to the SDK we link against. So this command actually evaluates to a path where the SDK lives. Do you see it? Yeah. It's a huge screen. OK. So we take all of this, feed it into the Swift compiler. We ask it to emit an executable for us, and we ask it to kindly put it inside our bundle directory in the file that has the same name as our project name. Let's try it. Okay, you can see that it has found both Swift files. And we can verify that inside the helloberlin.app bundle, there's a file called Hello Berlin. So, yep, done. Swift file's done. What else do we need to compile? Resources. Perfect. Okay, so we also need to compile asset catalogs and storyboards. Our asset catalog is empty, so we can ignore it, but we have to compile storyboards. And you compile storyboards using a tool called IB tool. Really, I didn't make it. Here, IB tool is a tool that compiles, prints, updates, and verifies interface build documents. So we do the same thing that we did with the Swift files. We do it with all the storyboard files. Sorry. It's just to wake you up, you know. So compile storyboards. Step number 3. The same thing. We say, hey, all the storyboards live here inside the base.l project folder. We want you to put it inside the bundle directory. Create a directory, and then we iterate over all storyboards and just one by one feed it into the IB tool and ask it to put it into the bundle directory. Okay, it found both storyboards, that's good. And we can see that inside our hello berlin.app bundle, there's now a folder called base.l project, and inside of it, there are 2 storyboards, storyboard.c. And this was the first surprise for me, that when you compile a storyboard, it actually compiles into another bundle that includes a nib files, and each of this has its own info plist. So it's really like info plists everywhere. Speaking of info plist, we also have to include the info plist into the app bundle because a valid app bundle has to have an info plist. Unfortunately, we can't use the one that lives in our source directory because it's not processed. I'll show you what I mean. So this is the one that lives in the source directory. You can see that there are some placeholders that we actually need to replace with the proper values. Again, these values are specified in the Xcode project file. We don't have it, so we have to hardcode everything in the script. How we're gonna do that is that we take the original storyboard, we make a copy into our temporary folder, because we don't want to modify the original one, of course. Then we replace all these placeholders with the real values, and then when it's ready, we copy it back. We copy it into the resulting app bundle. Good morning. That's step number 4. So this is the path to the original info plist inside the source directory. We want to copy it into the temporary directory. And then when it's done, we want to copy it back, copy it into the bundle directory. That's this path. These are some values that we will need. For example, the bundle identifier. It's hard-coded here. For modifying plist, Apple provides us with a tool called plist buddy. And you can use it, you can call it from command line, and it basically helps you to modify the plist, so you don't need to modify it at the text level. So we just ask our buddy, our plist buddy, to kindly set the CF bundle executable for us, the CF bundle identifier, and CF bundle name. And then once it's done, we just copy it to our bundle, app bundle directory. Let's do that. Okay, here you can see that it set all the value correctly for us. And we can also verify that the plist that's inside the app bundle here has the correct values. All right. Well, so we compiled all the storyboard files. We compiled all the Swift files. and we put the correct process info plist into our app bundle. I would give it a shot and try to run it in a simulator and see what happens. So let me just take the simulator and put it there. There's a tool how you can interact with simulator from command line. It's called simctl. So I will use it for installing the app bundle into the simulator. It goes like this: simctl, please install into the booted simulator this one app bundle. You see it's installing? Do you see it? You don't see it. Oh. You know, it was such a glorious moment. I'll do it again. But I'll just... Oh, no, it's a right corner, but I will put it to the left. I'll beat the system. Cool. You see it now? Oh, perfect. So I'll do that again. Okay. You see it installing? Now, okay, let's give it a shot. Okay, it works. Thank you. There's one catch, though. This isn't supposed to work. Anyone has an idea why this isn't supposed to work? You don't need to consign it for simulator, so it's fine. Exactly. Runtime libraries. Since we still don't have stable ABI for Swift runtime libraries, we have to include the Swift runtime to every single app bundle to make it run. But we didn't do that. It still works. Exactly. This was my reaction when I saw it for the first time. So it turns out that when you call Swift compiler like this, let me just put it into the verbose mode. I'll run the build script again. Okay. It turns out there's a default value for the R path, which is the path where the linker looks for runtime libraries. And the default value is this. And this is actually the place where all the runtime Swift libraries are stored in your computer. And since iOS simulator is not sandboxed, it can access whatever it wants. So it just uses really the runtime libraries that live on your computer, so you don't need to include them into the app bundle. So this was a huge surprise for me. And yeah, so if you build for simulator, you don't need to include the runtime libraries. All right. So we successfully built for simulator. When I was working on this, it took me like 4 hours to figure this out. And I was super happy and excited about like how smart I am that I just made it work. And then I decided to try to make it work also for device. It took me additionally 2 days to make it work for device. Most of the time, of course, I spend on code signing. And the reason is that if you do something wrong in the code signing phase, basically the only error you get back is that something is wrong. So you have to try something else, try something different, and it's just try and error. So it's really, really painful. So yeah, let's try it. We'll see. All right. Good morning. The first step, the easy one, is that we just need to somehow adapt our script to just accept some parameter so it knows when it should build for device and for simulator. So we just check for the -- device flag. It's easy. And then we adapt the code where we call Swift compiler So it has different parameters when we are actually building for device. So this is the path where we building for device. We say that the target architecture is ARM this time. We provide the SDK that points to the iPhone OS SDK. And of course, this time we really have to include the Swift runtime libraries. So we have to tell our linker where to search, where to look for these libraries. And usually, this folder is called frameworks. So we just follow the name, but it can be called whatever you want. So we say, OK, we will put it into the frameworks folder. And that's really it. So I'll get rid of this now. Spoiler. And I'll try to do the same thing. And I'll just try to run the script, this time for device. All is good so far. That's a good sign. Next step, we're almost in the end. Next step is Swift runtime. Yes, we have to copy all the Swift runtime libraries into the app bundle. So it's step number 5 here. We already know the source directory, because that's the directory that actually Swift compiler uses as default. Then we say, OK, the destination of all the runtime libraries is inside the app bundle, is the frameworks directory. Here is the list of all Swift runtime libraries we need. And then we just iterate over them and copy them one by one. OK. Let's verify that everything worked correctly. OK, and you can see that now inside the app bundle, we have a frameworks folder that has all the runtime libraries in it. Well, and then there's just one last step, step number 6, called code signing. And before we get there, let's relax for a bit. All right. I'll send you a link to the video later. OK. We're almost there. There are 3 sub-steps in the step number 6. The first one is the provisioning profile, and that's the easiest one. Because there's not really that much we have to do with the provisioning profile. The most complicated thing is that we have to find the right one to use. And then we just take it and we copy it into the app bundle, and we rename it to embedded.mobileprovision. All your provisioning profiles, or all the provisioning profiles on your device, live in library, mobile device, provisioning profiles. So these are mine. And since I did my homework, I already know that the one I need to use is this one. So I'll just put it here. So this is the one I want. And I just, this is the destination path, sorry. And then I just take it and copy it there. Let's try that. OK, you see that the file is now inside the hello-berlin.app bundle. The second sub-step is the entitlements file. You probably know that if you're working on something and you ask for some permission that is not the default one, the Xcode creates an entitlements file for you. And then it uses this entitlements file for code signing. The way it does is that it actually creates another entitlements file that contains some default values, and then it merges this default one with the one that's specific for your project, merges it together, and then uses this file as a parameter for the final code signing. We don't have any specific permissions in our project, so we can ignore that part, and we just need to create the default one. By the way, entitlements file is just a plist file, so everything is a plist. Okay, so again, we're using plist body for this, and this default entitlements file has to have two records, one specifying the application identifier that consists from your team identifier and from your app bundle identifier, and then you have to, for some reason, specify the team identifier again. Let's try to do that. Okay, let's verify that it's there. Oh, it's inside the temporary. Oh, sorry, I maybe forgot to mention that. We don't really need to copy the entitlements file into the app bundle. We really use it just as a parameter for the final code signing call. So that's why it lives inside the temporary directory. Yeah, so this is it. It's just a plist file with two records. Okay, final step, the code signing. Surprisingly, if you want to code sign something, you use a tool called CodeSign. CodeSign creates and manipulates code signatures. If you want to code sign something, you have to know your identity. So you can list your available identities by this short command. Goes like security find identity -v-p code sign, or something like that. Sign. No. Do you see the error? No. Oh, code signing. Thank you. Okay, so these are the identities I have here. Not only that we have to code sign the resulting app bundle, but we also have to sign all the dynamic libraries that live inside our app bundle. So here we iterate over all the dynamic libraries, and we code sign them. --force means that if the library was already signed, just forget it and just like sign it again. Timestamp equals none. I don't know what this means, but Apple is using it like this, so okay. And then there's an identity. Okay, and then the final step, final step, is that we sign the bundle itself. And here you can see one of the parameters is actually the entitlements file we have created before. Important thing: if you're code signing the final bundle, you always have to do that as the very last step, because the code signing means that it's like a verification that the bundle you created is the bundle that actually really arrived on the device, so it wasn't changed in the meantime. So if you're code signing and then you change it, of course it's no longer valid. And it took me embarrassingly long time to realize that. So the final code signing has to be always the last step. All right. And that's it. Some happy message in the end. and let's give it a try. The libraries. All right, so now we have the bundle. This is what it looks like. We have some storyboards in there. We have Swift runtime libraries. We have the executable. We have the plist file. And then we have some information about the code signature. And mobile provisioning profile, of course. So this should work. Let's give it a try. And that's the very, very final step. I mirror my device here to the left so you can see it. Then we can see my notes. So it's good. So I did this, okay. Unfortunately, there's no easy built-in way how you can install an app bundle into the device. So I have to use a third-party tool for that. The tool I'm using is called iOS deploy. And you do it the way that you first check for all connected devices, get the identifier of the device you're interested in, and then you just use iOS deploy to the identifier bundle hello berlin.app. Now I get rid of this so you can see it. Okay. Okay, it's installed. It means the code signing was correct. Now I'll try to run it. And it works. Thank you. And that's really all I have for you tonight. If you're interested in this, or if it was like too fast, or you want to learn more about it, I wrote a blog post, which is a very long blog post, about this. It's on my blog, in this address. And I'm here for your questions, or I'll be around having a beer. Thank you.
Two very quick questions. First one would be why? Second one, how?
Why? Because in Ableton, every 2 months, we have a hack week when we are allowed to work on whatever we want. And I knew that this was like such a huge topic that I would have never done it in my free time. So I really used basically the free time, or the hack time we had in Ableton, and just tried to reverse engineer how this works. And it leads to how. I basically use Xcode, and I use the detailed build log it produces, and I just try to like reverse engineer what was happening there.
Wow, amazing talk. Thank you.
Thank you.
There was, okay.
I have one note, because like Apple Configurator has a tool which allows you to install an app on a real device.
Oh,
actually.
really?
Like it's included in Apple Configurator. And my question is, do you use it in any place for real, or
No,
only
no,
for fun? Okay.
No. This is really just, this was just for fun, and yeah. Actually, I did use it for real just 2 days after I finished writing a blog post about this, because this taught me so much about this process. And then when later when I saw some issue during the build process, which never fails because of course like linker errors and stuff like that never happens, but when they do happen, it's really good to be confident about like understanding what's happening there. Oh, the linker failed. Okay, so it means that this part is wrong, or the code signing failed, so it means that this part is wrong. So it really taught me a lot.
So thanks for the nice talk. Maybe I have an application or a question, how, or if it would be possible to say, if you have already a complete signed app, wouldn't there be anything against it to say you exchange the bundle resources and sign it with a new identifier and provisioning profile? I mean, was anything against that?
Sorry, say it again.
So
I'm not sure I understand the question.
Say if you have an app that you have previously built with Xcode in a regular way, and then you could take that bundle and just exchange the bundle resources, so all the data files that are copied in there, and change the bundle identifier and so on, and the signature and so on. So you could basically, like, let's say if you have like kind of an application where you always have the same code, but different graphics or different configuration and so on, then, I mean, as I understood it, it would be possible then to exchange these files, change the bundle identifier and a plist and so on, and then re-sign it again and distribute it as a new app. So basically kind of like taking an app, something you did on your own, and then on the build server you just, no, it's really...
Startup idea.
So basically just to, if you say like maybe you have the same app, but you want to reskin it again and then publish it again. One of your apps.
I think you know the answer better than I do.
Actually, that's possible, and that's what a lot of scammers do. They download your app from the App Store, and then they use CodeSign to re-sign it with their own identity, and then they upload it again with a different name and slightly changed artwork. And they're cashing in on that. So that's a huge problem on the App Store because Apple doesn't really curate well enough.
And now you know how to do that.
I mean, the whole thing looks like you spent like a lot of time trying to figure out like what to do exactly. But couldn't you just like have gone through like when you build it in Xcode, it like kind of does all that stuff for you, but does it not do like the flags correctly, or like how come you couldn't just see the individual pieces of the command and then kind of work backwards from there?
No, that's actually what I did. But I tried to find the minimum thing I had to do. So if you see the log, the full log, there's a lot of things happening. And for example, the Xcode build system, it doesn't use this when it compiles the Swift files. It doesn't use this emit executable because it supports incremental builds, so it's like much more complicated than this. So I really try to understand what's happening there and then do the minimum thing as possible to build it. So that was the goal. And also another thing, you will see if you study the log, you'll see that the build system actually uses a lot of tools that are not publicly available for things, and you have to just find some workaround for that. I don't have a concrete example now because I did this 2 months ago.
No, I've seen that before too.
Yeah.
Not fair.
Okay, thank you very much.
Thanks.